Hello everyone. This session we are going to discuss about the meaning of factorial symbol and how factorial symbol can help you to solve problems in combinatorics. I mean in permutations and combinations. This factorial symbol can be used not only in permutations and combinations, can be used to solve probability of an event also. So learning of factorial symbol and proper use of factorial symbol is required for you. So in this second session on fundamental principle of permutations and combinations, I'll be discussing the meaning of factorial in and its application in solving problems. So let us first know the meaning of factorial in. What is the meaning of factorial in? How can you write factorial in? The factorial in we can write this manner: n factorial equal to n minus 1 n minus 2. It is basically product of first n natural numbers. So if you have stated it is the product of first 7 natural numbers, you can say that if it is product of first 7 natural number, that is factorial 7, we will be writing for it. Factorial 7 will be 7 into 6 into 5, 4, 3, 2 and 1. This if you multiply will be 5040. Factorial 6 will be 6, 5, 4, 3, 2, 1. This will be 720. Factorial 5 similarly if you multiply it will be 120. Factorial 4, 24. Factorial 3 equal to 6. Factorial 2 equal to 1, because it is product of first 2 natural numbers. Natural numbers start with 1 and then 2. So factorial 2 if you write, it is product of first 2 natural numbers, result going to be 2. Using the same definition on factorial, factorial 1 will be 1. But what is factorial 0? That factorial 0 has no link with this, that is factorial 1, because if you say factorial 0, it is product of 0 natural numbers, first 0 natural numbers. It is not possible. So at this moment I will say that by definition factorial 0 will be, this is by definition, factorial 0 equal to 1. Later on when we will see factorial means number of arrangements, we will state why factorial 0 equal to 1. I mean I can explain with different manner why factorial 0 will be 1. But at this moment, as we are learning here factorial 0 only, we are not finding any link with permutations or combinations here. We will say that by definition factorial 0 will be 1. But never say that factorial 0 is going to be 1 and factorial, if factorial 0 is 1 and factorial 1 is also 1, then can't I say that 0 equal to 1? Does this imply? No. We cannot compare factorial signs this manner. So this is a wrong statement if you say that 0 equal to 1. So factorial 0, 1, factorial 1 also 1, there is no confusion in it, up to 1, starting from any number to 1, but with 0 we will define factorial 0 as 1. Okay. So now with the help of factorial symbol we can establish something like this, like when you are writing, when you have seen that we have to find factorial 7, you are writing 7, 6, 5, 4, 3, 2, 1. At any stage, suppose you remember the value of factorial 5 or factorial 6, you can use the result here. So I am going to generalize that part, like factorial 7 I want to write 7 into factorial 6, because it is product of first 6 natural numbers. We can see that 6 natural numbers are there. So if somebody remember the value of factorial 6, can write here as 720 and then multiply to give here the result as. So factorial 7 you can evaluate this manner by writing in the form 7 into factorial 6, 7 into 720. If you remember factorial 6 value, then multiplying the result will be 5040. 6 factorial also you can write 6 into 5 factorial, this manner for better calculation. So what about factorial n? It is product of first n natural numbers, n minus 1, n minus 2, n minus 3, 3, 2, 1 like this. If you do not want to continue with this, n minus 1, n minus 2 up to 1, you can stop your calculation here. This is going to be n into factorial n minus 1. What about n plus 1 factorial? This n plus 1 factorial will be similar logic we can apply. It will be n plus 1 into n factorial. Okay. So when it is required, you can apply this concept. Suppose in a calculation, you were asked to simplify this thing. 1 by factorial 8, 1 by factorial 9, 1 by factorial 10. How are you going to simplify? Factorial 8 is factorial 8 only. Why will I keep same? Because out of factorial 8, factorial 9 and factorial 10, this factorial 8 is the least one. But 9 factorial, this we can express in terms of factorial 8. Okay. 9 factorial is this. And 10 factorial, we can express this also in terms of 8 factorial. How? You write 10 into 9 into 8 factorial. Okay. So all these can be written. These three expressions are expressed in terms of factorial 8. So what about this thing, that left hand side, or no left hand side here, just simplification. This expression is going to be equal to 1 by factorial 8, 9 into 8 factorial, and this one was 1 by, so take 1 by 8 factorial as common. The result will be this plus 1 by 90, or 1 by 8 factorial, you take 90 as common here, it will be 90 plus 10 plus 9. So this is 109 by 90, we are writing 10 into 9 into factorial 8. So this is nothing but 109 by factorial 10. So we have learned how to add by calculating the LCM, We can remember this fact also. The LCM of 8 factorial, 9 factorial, 10 factorial is equal to 10 factorial only. Okay. If consecutive numbers are there in this manner, we can write factorial symbol without hesitation. The problem arises this manner. See, you have to find the value of x when equation given this manner. That is x by factorial 7 equal to 1 by factorial 4 plus 1 by factorial 6. These are three consecutive integers. They are factorial. Their LCM, just like previous one, will be 6 factorial. Then how can we add all these here? So it will be better to express in terms of 4 factorial, but 6 factorial is 6, 5 into 4 factorial. So we will be taking 30 here, 6 here and 1 here. So this will be 37 by, so x by factorial 7 is equal to this thing. So x will be 37 into 7 factorial by 6 factorial. 7 factorial you can write 7 into 6 factorial by 6 factorial. So answer will be 259. Okay. So this way you can solve problems related to factorial. Let us see another problem. They have asked to express this one into factorial. How can it do it? It is starting with number 1, you see, starting with 5, 6, 7, 8, 9, 10. So if you say that it is product of 12 natural numbers starting from 1, it is not true. Why? Because 1, 2, 3, 4 are not there. But if we write in next step this as 1, 2, 3, 4, 5, 6, this manner up to 12, and divide the result by which you have multiplied here, then it is very simple. We can easily express in terms of factorial. There you can see the numerator is product of 12 natural numbers, factorial 12, and this is factorial 4. Done. How to solve number 2? That is 4, 6, all these are even numbers. So you start writing 4 as 2 into 2. Write this way, that 4 is equal to 2 into 2. Write it there. Just a minute. 4 you write 2 into 2. 6 you write 2 into 3. And 8, 2 into 4, 2 into 5, 2 into 6, 2 into 7. So from each bracket you take 2 common. So it will be how many brackets are there? 6. 2 to the power 6, 2, 3, 4, 5. 1 is missing. 1 can be multiplied. So if you multiply by 1, it is going to be 2 to the power 6 into, you take 1 here. It is factorial 7. So this result also expressed in terms of factorial symbol. Another very interesting question we are going to discuss now, that is factorial 2n plus 1 by factorial n equal to this thing. How to prove it? So how to prove this thing where factorial 2n plus 1 by factorial n expressed this manner? So you start with the numerator, that 2n plus 1 factorial, that divided by n factorial, you can write as 2n plus 1, reducing by 1, then 2n, then 2n minus 1, 2n minus 2, 2n minus 3, this way 4, 3, 2, 1. You understand? Factorial n, you keep this manner. Because I am observing the right side, no factorial n there in the denominator. So there is a chance of getting cancelled from numerator and denominator. Now there are how many even terms and how many odd terms? If it is factorial 5, 3 and 1, 3 odd, 2 even. If factorial 7, then 4 odd, 3 even. Isn't it? Factorial 7, when you write, this is 7, 6, 5, 4, 3, 2, 1. How many odd factors are there? 4. How many even factors are there? 3. So when odd factorial is there, what I am going to say, then number of odd factors will be 1 more than number of even factors. So here 2n plus 1 is sum of these two. This n plus 1 odd factors and these n even factors are there. So when you collect all the even factors, 2n minus 2, of course next one will be 2n minus 4, 4, 2 like this. These are n factors and remaining 2n plus 1, 2n minus 1, these are n plus 1 factors. Okay. Then what you are going to do, you are going to take 2 as common from every term here. So if you take 2 common from here, it is 2. 2 from here, 2. 2. This 2 is coming n times. This multiplied by n minus 1, n minus 2, 3, 2, 1 as before, and these odd terms remain unchanged. 2n plus 1, 2n minus 1, 3, 1. This divided by factorial n. Now you can see that this is factorial n, this is also factorial n, they get cancelled. So if they get cancelled, then what is the result? 2 to 2 n times, it will be 2 to the power n, and here it is 2n plus 1, 2n minus 1, 3, 1 like this. Just little bit rearrangement will give you this answer. It has come already, 2 to the power n. What they have done, they have started from the end. This they have taken there and 1, 3, 5 writing. We got the answer here. Okay. Now let me discuss the next part of factorial sign, where I am going to express, I am going to say that every factorial symbol can be expressed, every factorial symbol can be expressed as product of primes. Why I am saying so? Because you know, if there is say factorial 6, factorial 6 is what? 6, 5, 4, 3, 2. See, 2 is coming repeated in some cases. Okay. If you say factorial 7, there also 3 is coming common in some factors. So a factorial sign always you can express in terms of prime factors. I mean, prime factorization is possible with factorial symbols. Let us make one experiment with factorial 7. What I was saying, Factorial 7 is what? 7, 6, 5, 4, 3, 2, 1. So this 6 is 2 into 3. Here also 2 into 2, 2. So how many 2's are there? 2 is occurring 1, 2, 3, 4. 4 times. 3 occurring how many times? 3 is occurring here also. So it is going to be 3 square. Next which one? 5. 5 is occurring once. 7 is occurring once. So factorial 7 we can express in terms of prime factors, which you say prime factorization of a number. As factorial 7 is a natural number, so it will have a representation in this form. In terms of prime factors, we can, all of you understand. So when somebody has asked you to check whether 33440 divisible by 5 cube, what you did? You have taken the help of prime factorization. What is that? You have written that 3, if you go by writing in the form of prime factors, it is 2 to the power 5 into 5 into 11 into 19. See, prime factorization is there, 33440. I remember the result I have written. You can get it. That 2 to the power 5. What is exponent of 2 here? 5. Exponent of 5 here? 1. Exponent of 11? 1. Exponent of 19? 1. This is prime factorization. And this is not divisible by 5 cube. Why? Because its prime factorization doesn't contain 5 cube. So it is not divisible by 5 cube. So two things are very clear, that factorization, factorial symbol on any natural number, it will give us the number in terms of prime factors. And second thing, which you have done before, the number is divisible by another number or not, that is understood by its prime factorization. Isn't it? Now, we are going to learn a very interesting thing here, that is what is exponent of prime p in factorial n. This we have just seen in factorial 7. Exponent of 2 is 4. Exponent of 3 is 2. Exponent of 5 is 1. So what will be the general formulation of exponent of prime p in factorial n? We will be using the symbol for it as EP on factorial n. Okay? Exponent of prime p on factorial n will be writing this manner. Okay? I am not going to derive the formula, I am just going to tell you the application. Later on, when number theory concept you have, I will give you a proof. Right now, know this one as formula. The formula for exponent of prime p in factorial n will be this thing. If you are not familiar with this symbol, which is known as greatest integer function or modulo function, I will explain. So what we are going to write here? We are going to write how many times a prime factor p of factorial n will be there. This is given by modulo n by p. We read greatest integer function as modulo n by p, modulo n by p square, modulo n by p cube. Just remember, very simple thing, when you are using this symbol on a number, say 2.33, this will give us integer. When you are writing on root 3 is 1.732, it will give us an integer. It is so simple. Just remember this way. If I say that what is modulo 0.77, your answer will be 0, because it doesn't give any integer. Okay? So what about modulo, say one number is coming 7.132, this is also 7. Remember, it will give you the integer which is not exceeding the given number. This you cannot write 8, it will be 7. This you cannot write 2, it will be 1. So this has a name which is known as GIF, that is greatest integer function. GIF of x, it means we will get the smallest integer, we'll get the integer which is not exceeding s. Okay, so how many times the prime factor p occurring in factorial n will be getting by this formula? I have written dot 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 dot. You can ask me why I am not writing the last expression. I don't want to bring any confusion among you. Just remember, we'll stop there when we'll get a fraction like this. So in EP factorial n, we'll stop our calculation when we're getting a fraction, proper fraction. Like if we want to find exponent of prime 2, which we have seen here. Exponent of prime 2 in factorial 7 is 4. We are going to prove it by formula. Exponent of prime 2 in factorial 7. Prime is p is 2 here and n is 7. That you all can see. So this thing going to be modulo n by p. N means 7. 7 by 2. 7 by 2 square. 7 by 2 cube. Should I proceed? No, because 7 by 8 is a fraction. We stop. What is 7 by 2? It is 3.5. What is 7 by 4? It is 1.75. What is 7 by 6? 7 by 6 is a 7 by 8. It is a proper fraction. So all other terms going to be 0. Even this one also 0. This one modulo 3.5 is what? 3. This is 1. So answer is 4. We have seen that prime factorization of factorial 7 contain 2 4 times. So it is proved over there. Any factor, how many times it occurs in factorial n, that you can find. Obviously that number will be less than n. So question like this, calculate exponent of 3 in factorial 8. We are going to get it by E3 8 factorial. How will I write? This will be 8 by 3 n by p plus n by p square plus n by p cube plus this way. 8 by 3 is how much? It is 2.67, something like this, approximately. See, 8 by 9, it has become a proper fraction. We should not continue. All are going to be 0. 8 by 9 also. So answer is 2. So prime factorization of 8 contain 3 twice. Okay. If prime factorization of, okay, let us take another example. Exponent of 7 in factorial 20. How will I do? This is going to be 20 by 7 plus, we will not proceed, 20 by 49 is a fraction, other terms going to be 0. So this is 20 by 7 is 2 point something, it will give us 2. So 7 factorial 20 will occur twice. It's quite obvious. It will occur in case of 7 when you are writing factorial 20. In this form 20, 19, it will occur in one case in 14 and then in another case in 7. It's like this. Okay. So it will occur twice. This is very helpful. We can do any calculation on prime factorization based on this concept. Okay. So all these can be done. Now we are going to solve a very interesting question which, if you don't use the formula we have just learned, can give you some trouble. How many zeros are there in factorial 200? Such a huge sum. They haven't asked in factorial 50, factorial 100. They have asked in factorial 200. Okay. So 0 means 2 into 5. Okay. Even if 2 square into 5 is coming, we will say only 1 0 will be there because 5 is occurring once, 2 is occurring once. So we will get 1 0. If it is coming 2 to the power 10 into 5 to the power 6 in prime factorization of a number, then how many zeros will be there? Number of times 2 and 5 occurring together. Here 2 and 5 should have same exponent. Okay, I am getting a 10 over there. This into 2 to the power 4. So I will be getting 6 zeros over there because 2 into 5, this factor together, I mean 10, occurring 6 times, so 10 zeros will be there. So in factorial 200, if you want to find how many zeros, you need to find exponent of 2. EP factorial n formula, you remember? We are going to do it for what? 2 and 5. E5 factorial 200. How can you find it? So simple, 200 by 5 plus modulo 200 by 5 square plus modulo 200 by 5 cube. 5 cube is 125. 5 to the power 4 is 625. 200 by 625 is a fraction, proper fraction. Stop. 205, 40. This one is 200 by 25, 8. This one is 1. So it is occurring 49 times. In prime factorization of factorial 200, 5 will be occurring 49 times. Let us see about 2. E2 200, it will be much more than that. Much more than 49. See, here only it is exceeding. 200 by 2 square, 4. 200 by 2 cube, 8. 16. Then 200 by 32. 200 by 64. 128. Will not proceed because next one 256. It will be a proper fraction. So we will stop our calculation here. This is coming 100, 50, 25. This one 12 times because 12 point something. 12 plus a proper fraction. It will be 0. This one 6 plus proper fraction. 6 times. 192 plus proper fraction. 3. This is 1. So it is coming 4, 10, 22, 47, 9. 197 it is occurring. But to get number of zeros, you need 2 and 5 together. Are you getting 2 and 5 together? Here 197 times? No. 5 has occurred in prime factorization of 200. 5 has occurred 49 times. 2 has occurred 197 times. Other factors we don't care because we need 5 into 2 pair. 1 5 into 2 pair will give you a 10. So this is going to be what? How many times? 5 into 2 together? It is 49 times. Then 2 to the power 197 minus 49. 48. 148. 2 to the power 148. This 10 is occurring 49 times. So number of zeros at the end of factorial 200, number of zeros is going to be equal to 49. Very interesting. Okay. I have done it with factorial 200. You must do it with factorial 100, factorial 50 and write your result in the comment box. It will be highly appreciated. You do your experiment with factorial 400, how many zeros are there. Today your work will be on it only. Okay, write comment box. I am giving you two problems only. Find number of zeros at the end of factorial 100 and factorial 400. Okay, you must write your answer over there. Now today's class, I am going to end the class by giving you one problem to think. Given a number n, find the largest prime number less than n that divides factorial n. See how interesting is this? Factorial 50. What is the largest prime number which will divide factorial n? Factorial 50, that you can see, no? Because 47. But for any number, how to find it? You will tell me. You will write in comment box over there this problem. Okay? Now, just before I leave, I would like to discuss with you another problem where I am going to tell you, show that factorial 57 plus 1 is not divisible by any number, not divisible by any number between 2 and 57. Just it's an ordinary sum I'd like to discuss before I leave the class. Factorial 57, if you write, it is 57, 56, 55, 4, 3, 2, 1, you know. That plus 1. Number 57 factorial completely divided by any number between 2 and 57 because its prime factorization contain all the numbers. No remainder is remaining. So if you divide by 57, this number no remainder. If you divide by 55, no remainder. Divide by 3, no remainder. But if you write plus 1, every time remainder is 1. So it is not divisible. So factorial 57 plus 1 never divisible by any number in between 2 to 57. This is another problem for you. What is the largest number divides factorial 57 plus 1? Think today. If you have the answer, you write in the comment box the answer to these questions. Thank you.